Okay, in this lesson, we're going to be looking at parabolas that are no longer centered at 0, 0, but again, they are going to be shifted either left, right, up, down, or any combination of those. Okay, so in the last lesson, the vertices or the vertex was always at 0, 0. In this case, we're going to shift those parabolas either right and up or whatever it is. Notice the vertex is HK, whether that's a sideways parabola like this one is or an up-down parabola, the vertex is always HK. Okay, we have a whole other set of formulas for parabolas that have been shifted or translated in some way. Here they go. I still want you to notice, though, that when it's an up-down parabola, it's the x quantity that's been squared. When it's a right-left parabola, it's the y quantity that's squared. I also want you to notice that whether it is an up-down or a left-right, the h is always paired with the x, and the k is always paired with the y. Every single time, no matter what kind of parabola it is. You might want to write down here, if you want to, that the vertex is HK. I think you'll probably be able to figure that out, but it is true that the vertex is HK for both up, down, and left, right parabolas. Okay? All right, so this first example asks us to find the standard form of the equation for a parabola that has a vertex of 1, 2, and a focus of 1, negative 2. So we're just, you don't have to graph this to do this. If you can do it without graphing it, that's fine. I just sort of think it's helpful to have a picture. So what I know is that my vertex is 1, 2. So I'm going to plot that point and I am going to label it. My vertex is 1, 2. What I know then is that my h is 1 and my k is 2, because that's how you find the vertex. Okay, so I'm actually going to just write this down here. My h is 1, my k is 2. I already know that. Okay, then my focus is at 1, negative 2. So my focus is at 1, negative 2. I will label that one too. I know that the focus has to go inside the parabola, so I know this is a parabola in this case that opens down because the focus has to be inside of it. Okay, because it's an up-down parabola, I know that the x value is the one that has to be squared. All right, so I know that I'm going to be using this set of formulas here. I lost my absolute value symbols here. I'm just going to group all these here quick. Hang on 1 second, sorry. All right. Oh, that didn't work very well. Okay, I'm using this set of formulas here. Again, it's an up-down parabola, so I know my x quantity has to be squared, and so I need to come up with this set of equation, or the equation for that right there. Okay, I already know what h and k are. I wrote them down up above. What I need to know now is to figure out what p is. Okay, so I need to think about the information I have to figure out p. And luckily, I know that the focus right here is h and then k plus p. So I'm just going to write this down. My focus is 1, negative 2. So, and I already knew that h is 1. And this has to be k plus p. And I already know that k is from up here, where my vertex is. My k value is 2. Okay, I already know that. So that means I can make a handy-dandy little equation. K plus p equals negative 2. K I already know is 2. So then p will be negative 4. It makes sense that p is a negative value when it's a down parabola. If it was an up parabola, I would expect p to be a positive value. But since it's a down parabola, downwards parabola, p should be a negative number. Okay? So now what I'm going to do is I'm just going to go back to this standard form equation and I'm going to plug in everything I know. And I've got it. Okay, so it goes like this. X minus my h value, which I know is 1, equals my p value is negative 4. So 4 times negative 4 will be negative 16. And then y minus my k value, which I know to be 2. Okay, and that is my standard form for that particular problem. All right, Here, I just want to point out too that you can put these on your graphing calculators and graph them to get some more information if you would like. If you want to put them into your graphing calculators, you have to have them solved for y. This particular problem is not solved for y, so I'm just going to practice solving it for y so that we can get it into the right formats to put into our calculators, okay? So to solve this one for y, we want to take the square root of both sides. Those cancel each other out. And so I have y minus 4 equals, don't forget that when you take a square root of something that's been squared, you have to have the plus or minus in front of it. So don't forget that. And then I will move 4 over to the other side. So it should look something like that, okay? Your calculator, or some calculators actually, some will, but some calculators won't do the plus minus signs. So I'm just going to teach you a way that's safe for everybody, no matter what kind of calculator you have. This is really two equations, okay? So in y1, you're going to put 4 plus the square root of 8 times x minus 3. And then in y2, you'll do 4 minus the square root of 8 times x minus 3. So when you go to your calculators, you need to enter in two equations so that you can get both parts of the graph, okay? So here we go. I'm going to go to my calculators. I actually already have this one in here. If I go to my y1 key, or y equals key, you can see that they are both in here. And then just remember, if your window is set weird, a good place to start is to do the standard window, which is zoom 6. That changes that window to negative 10, 10 by negative 10, 10. So this is my graph of a sideways parabola. It is not a function, by the way, just to bring that vocabulary back to you. It does not pass the vertical line test. And there are many x's that have more than one y. So for instance, when x is 1, 2, 3, 4, 5, 6, 7. When x is 7, y could either be this value, which looks like it's about 9.5, or this value, which looks like it's about negative 1.5. So this is not a function, but it is a sideways parabola. Okay? All right, then here's an equation that's not in standard form, but I want you to see that it can be put in standard form if you use the little trick of completing a square, which it's been, we always practice that. Not always, but we practice that once in a while, and then you always wonder, when am I going to use this? Why did they teach me to complete the square? Here's why. When you want to get conic sections into standard form, it is helpful to complete the square. In this parabola, what I know is that it's the y quantity that's been squared. And so because it's the y quantity that's been squared, I know that it is going to be an up-down parabola, just so you know, okay? Whatever variable has been squared, in this case it's the y, it won't always be the y, but whatever variable has been squared, I want you to leave anything with that variable in it on the left side. So I want you to leave that over there. So I'm going to leave y squared on the left, and I'm going to leave 2y on the left. Anything else needs to go to the right side of the equal sign. So I'm going to move that 6x, negative 6x over and make it positive 6x and move the 13 over. Combine it with the 0 that's over here and see what I get. All right. So I'm leaving a space on purpose. This is going to end up being 6x minus 13 on the other side. When I combine it with this 0, 0 minus 13 is negative 13. Okay. Then you're going to complete the square. So I'm going to put a blank here, and I'm going to put a blank here, okay? I will complete the square on the left side with the quantity that's been squared. So to do that, I'm going to take half of this number right here. So half of 2 is 1. And then I square this 1. 1 squared is 1, which goes here. And nothing has been factored out of the left side, so I don't need to multiply it by anything, and I can just put a 1 here. Okay, then I'll simplify that right side. And negative 13 plus 1 is negative 12. And then, if this is a parabola, you should be able to factor something out of here. So I can factor a 6 out of that right side. And this becomes x minus 2. Okay, so this is now in standard form, okay? And then I can find its focus and its directrix and all of that good stuff. Okay, here's my equation. So I've got that in there. I can take that equation and pull the vertex out of it. Remember that the vertex is hk. So in this case, since it goes y minus k, remember opposite signs right here. So k is -1, and this goes x minus h, so my h is 2. Okay, so my h is 2, my k is -1 for my vertex. My focus is h plus p and k. The problem is I don't directly know what p is, but I know that this quantity right here has to be 4p. So if you think about that, 4p equals 6, divide by 4. P is 6 over 4, or 3 over 2, or 1.5. We'll just use 1.5. I think this book does more decimals than it does fractions with these, so we'll leave it at 3.5. All right, so my focus is h, which is 2, plus p, which is 1.5, and then my k value, and my k value we know is -1. I'm going to simplify this. 2 plus 1.5 is 3.5, -1. Okay, and then my directrix is h minus p. Okay, so my directrix is h, which is 2, minus my p, which is 1.5. So then this goes to x equals 0.5. That's my directrix, okay? So that tells you that my directrix is a vertical line, okay? It is a vertical line. All right. If I wanted to graph this, I certainly could graph this really quick. My vertex is at 2, -1. My directrix is x is 1/2. Okay. My focus is at 3.5, -1. So I know that it goes something like that. Okay. All right, then we're going to look at how to apply these. So what it talks about is that parabolic curves are used a lot in sound reflection and light reflection and radio waves and electromagnetic waves, all kinds of good things. So we are going to look at an example. Sorry, I need to erase this. At an example where it talks about football announcers on football TV wanting to place a microphone in the optimal place so that it can reflect the best sound it possibly can. Well, the best place to put the microphone so that you can capture the ultimate sound from anywhere along the curve would be to put it at the focus. Okay, so that means that the microphone in this case should go right here. The microphone should be at the focus. Okay. What it also tells you is that the reflector that it's going to put behind the microphone is 3 feet across. So basically that's telling you the focal width. And if you remember, the focal width is how wide the parabola is at the focus. So this distance right here is 3 feet, which makes this distance 1.5, and this distance 1.5. Okay? We will just call the vertex 0, 0. We can call it anything we want, but we'll just say that it's at 0, 0 so that it's nice and easy. We can assume we can call this an up-down parabola too. Typically microphones are up-down instead of to the side, but that's the way it is, okay? So what I need to do is I need to figure out what P is, because I need to figure out how far this microphone should be from here. What I know is that this reflector piece, okay, back here, is 1 foot deep, okay? So this is what I know if I kind of think about this, okay? I can find a point that's on that parabola, okay? I can find a point that's on the parabola because here's the deal. It tells you that this piece right here, this, is 1 foot deep. Is that what it tells you? Yeah, okay. So this point right here on the parabola, this point on the parabola is 1.5 to the right and 1 up. Okay, so that's what you need to figure out. Yeah, that's what you need to figure out. So you need to figure out then what your p-value is. Okay, you need to figure out what your p-value is. So you're going to use this handy dandy little formula right here. Okay, you're going to plug that coordinate into that equation. Okay, so this is what you know. You know that you have x is 1.5, so 1.5 squared equals 4. I'm trying to figure out what p is, times my y value, which is 1. Okay, so I have 2.25 equals 4p, divide by 4. P is about, let's see, 0.5625. And this is going to be in feet because we measured this to be 1 feet. Our units were in feet already. I think it's kind of hard to just picture this in feet, so we're just going to convert it to inches. You don't necessarily have to, but I think it's easier to picture. So in 1 foot, there are 12 inches. And then you're going to get about 6.75 inches. Okay? So this is what I'm going to tell you. Your microphone right here, has a p-value of about 6.75 inches. So what I can say is that the microphone, I'm going to just make a sentence, okay? Microphone should be about 6.75 inches along the axis, or from its vertex, I'm going to say that, from its vertex along the axis. Okay, because you want it lined up with the vertex so that it's on line of the axis and it hits the focus directly. Okay, and that should do it for that lesson.